All right, so notice I have no Python interpreter configured. So I'm going to do the configure Python interpreter. I'm going to select it, and I should see 3.7 in the drop-down list. When I hit OK, that error should go away, and I should get the option to play. Stefan, could you find me the book so I can have it next to me just in case?
Sure.
All right, so when you are looking at these, I had book numbers, which is apparently not a good reference, but these numbers here is telling you it's Chapter 3, Section 1. Some of these have changed, and I will try to get those fixed, but look at what the name is next to it. That generally does not change. So 3.1 is relational operators. So it's a good idea to, if you want to have your book beside you when you're doing this, and I'm going to do the same thing because I work in multiple languages, it's good to have the reference. So step 1, write a statement using the variables below and a greater than sign that will evaluate to true. Write a print statement with the statement in parentheses. So I give you a sample answer, print a greater than 3, and if I run it, that should evaluate to 2 and true, and it does. So I try to give you samples when I think things might potentially be unclear. So step 2, write a statement using the variables below that compares 2 of the values to see if they are equal. Write a print statement with the statement in parentheses. So I'm going to have 2 print. I'm checking to see if they are equal. A equals equals B. And remember that the equals equals is the comparison operator. And then 3, write a statement using the variables below that compares 2 of the variables to see if they are not equal. So I can actually pretty much reuse the same statement. Print A not equal B, and that should evaluate to true. And then for 4, write a statement using the variables below that uses the less than or equal to operator. Write the print statement with the statement in parentheses. So I'm going to have print C less than A. That should evaluate to true. Make sure you are doing the appropriate spacing. And you should be testing probably at the end of each one of these. So
Didn't it say the directions less than or equal to?
Thank you. Less than or equal to A. And then I can rerun it. And so that gives me true, false, true, true. So what I did before was just less than. This is less than or equal to, and make sure that you're double checking that. Okay, so 3.2, the if-else statement. Add code below to determine if age is greater than or equal to 18. Depending on the answer, display the appropriate statement. You are old enough to vote, or you are not old enough to vote. Use the if-else structure. So I've already got for you the age equals int input. How old are you? And this matches with 3.2 in the book. And so it's going to do if age greater than or equal to 18, and then you have to put in a colon to make sure that it's accepting it. And so this is a integer. It's not a variable. That is the solid number that we're comparing it to. Then we will print you are old enough to vote. Otherwise, and you need a colon there, you will print you are not old enough to vote. Now I'm getting an error here. No, it's the indentation includes mixed spaces and tabs.
Just do reformat code.
Right. And the way to fix that is code, reformat code. That didn't fix it. Spaces shouldn't matter in comments.
Yeah, I get that too. When it gives you an error when that commented on.
Switch back up and press tab and see if it does it. That's typically what I do to fix that.
For right now, I have the more options of ignoring errors like this. Over indented. Oh, that could be why.
Oh, okay. It's mad because you're not using block comments. So
We'll have to
just
go back.
3.7's more series on comments now.
And some of this stuff which worked in a prior version of Python, I don't know why it's saying this is over indented.
Because it's reading off of the comments, and then you're indenting from the comments as the start of the code.
For right now, I'm going to,
You might get troubleshoot it later.
yeah. So you'll see that sometimes errors come up when they change versions, so we're going to ignore errors like this for right now. And we'll figure out how to fix that later. Okay, so we do want to test it after each one. So how old are you? And I am old enough to vote. So the next one, 3.2.
3.3.
Hang on. So I've got 3.2, the if-else statement,
You
and,
just did that one. That's the voting one.
oh, thank you.
That's why I say 3.3.
So 3.3, comparing strings. Complete the code below so that if the user input matches the password, it will display that is correct. Otherwise, display that is not correct. So I have set the variable password equal to narwhals. I have the user password equals input. Please enter the password that will come in as a string. So we need to do a comparison here. And you'll notice from comparing strings, it is case sensitive. And so we just need to check to see if they are equal. So if password equals equals, that's our comparison operator, user password, and don't forget your colon, then we're going to display or print that is correct. Otherwise, we are going to do an else, print, make sure you have your quotes, that is not correct.
I have those transposed. Apparently it doesn't make a difference because I got a green.
It's checking to see if you have syntax errors. It's not checking to see if you have logic errors.
Because I had user.
Oh, switching order on that? They're exactly the same because if you're not doing a greater than or less than, it doesn't matter what order they're in. It's just saying, are they equal? So again, more than one correct path.
Yeah, it doesn't matter, honestly. Because compared to...
So I'm going to enter the password, and you should test it. And so I'm putting in narwhals, and that should tell me that is correct. And you could test it both ways. I'm not going to go that far. So this is section 3.4. And again, the page numbers may vary depending on which version of the book you're in, but the sections should be the same. So this is if, elif, else. And so we're finding that some of the section numbers have changed, but the section titles have not. So complete the code to accept a number between 1 and 5 from the user and display a Roman numeral for that number. If the number entered is not between 1 and 5, have the else statement display that is not a valid number. So we're getting the input and we're converting it to an int. So by doing the int here on the input, we're taking the string and making it an int. So now we can do the comparison, and we can do if number equals 1, print, and then we're going to do elif number equals 2, print the Roman numeral 2, elif number equals 3, print elif number equals 4, print elif number equals 5, print and then else, this is what happens if nothing else is triggered here, print that is not a valid number. Now we should check it, and typically when we're checking code like this, we can check for good, bad, or ugly data. So we're going to do it 3 times. So I'm going to run it. And 2 came out as 2. That's great. We're going to run it again. And I'm going to put in 22. This is a number, but it is not a valid number. So this is bad data. That is not a valid number. Now I'm going to do it with ugly data. And this is something you do not have to catch this at this point. But this is what we would consider an abnormal end to the program. When we get to chapter 6 or 7, we will actually figure out how to catch these errors. And I just wanted to show you that this is checking to see that you've entered a valid number, but not if it's a number. And you do not have to do that. That would go a step beyond. But just know that that would happen if somebody put in the wrong. And that error is fine. You do not have to fix it yet. Buffet prices are based on a person's age. If the person is a senior citizen, 62 or over, the charge is $9.89. If the person is age 12 to 61, the charge is $12.89. If it is a child under the age of 3, they eat for free. If the child is between 4 and 11, they are charged 99 cents for each year of age. Complete the code below. Customer age equals int, input, how old is the customer? Cost equals 0. We're initializing the cost and assigning the correct price to this variable. We're going to complete the code, and then it will format, print your cost for a customer who is, and it's converting it to string, customer age plus years old is $ plus, and notice when we're doing currency, we embed the $ into our string plus format of the cost. So all we're calculating here, and I'm doing this deliberately so you don't have to write the whole program, you just need to do the if-else statements. So we're going to do a series of conditions. So the first thing is, if they are 62 or over, if customer age greater than equal to 62. There are two ways I could have written this, assuming integers that give us the same result. It can be greater than or equal to 62, or it could have been greater than 61. That would have done exactly the same thing. Cost equals 9.89. Elif, okay, we're doing this as a nested if. So the next one, nope, we're going to do an elif here if, let's see, I want to see their sample. Sometimes you can solve things in multiple ways. This is doing the series of conditions testing. It goes with $314 figure, and yeah, it's got a sample in there. Your sample is figure 315 nested decision structure. And so we're going to follow along this, which is ifs and elses, not the if-elif structure. So when we're nesting it here, this is so it's dropping through. We're doing else, and then we're going to do if age 12 through 61. So we're going to do customer age, and I'm going to do greater than 11 just to show you we could have done this either way. I'm just rechecking my code. And we're going to print, I'm sorry, no, we're just going to assign cost equals 1289. And then we're going to do else if customer age greater than three. Now we're going to do a calculation. Cost equals customer age times 0.99. And this is why we had to convert the customer age to a int right here. Otherwise, if we'd left it as a string, we couldn't have multiplied by it. So that's why that was important. Yeah, question?
It says if they're under -3, it's free.
Right. So this, I'm still working on the if the child is between 4 and 11. So it's greater, that would fall into here because it's sort of dropping through it like a filter. So this is greater than 3, not greater than or equal to 3. But that's a good question. So then we're going to do an else, and this is just anything else that comes up. We can simply print.
You have a question from a student. And,
I used elif statements instead.
there's really no difference in all honesty, in my opinion.
It works.
It does. It works perfectly fine, and I will give you full credit for that. Just be aware that this is the format that the book was showing you for this. And so there's a difference between them because this is checking it inside of it instead of looking for a, it's two ways to approach the same thing. So this is, as long as it worked properly, you're fine. And I typically accept either on that. It's showing you two different ways to accomplish the same thing.
Okay.
And so typically with the book exercises, the goal is that you actually match the pattern in the book. But for me, as long as you have a working pattern, you're good. And so, oh, here I'm not supposed to print anything here. I'm supposed to do cost equals 0. And that should format it correctly, so we're going to go ahead and test it. I'm not going to test all of the options. I'm just going to test for the customer age greater than 3. And again, these videos will be up if you want to sit through them again. We'll see the customer is 2, and the cost for a customer who is 2 years old is $0. So that is correct. And you should go through and test all of them. Typically, I read these. So 3.5, this is our logical operators. Using the variables below, combine relational comparisons using logical operators. 1, write a print statement using the AND operator that will evaluate to true. So in 3.5, well, look for the one that's logical operators. Oh.
I think they're like flip-flops in the book or something.
Yeah, they sometimes change that. So the more important thing is the title. So we have a series of conditions here, and here we have logical operators. And so in some programming languages, you don't use the actual word and. Here so logical operators, we're going to be using and or. So we want to use and, or, and not's the exclamation point. So 1, write a print statement using the and operator that will evaluate to true. So we can check print if D equals E, and notice those two do match, and if F is greater than E, print, oh no, I'm just doing the print. So this should just evaluate to true. So we need to have a parentheses here because we're just doing the true or false, not an if statement. So we don't need the if, we just need the and. I apologize. I've been going back and forth. So we just need print D greater than E and F greater than E, and that should just evaluate to true under 3.5 logical operators. So we'll test it. And we're just going to hit 2's to go through the other stuff. So logical operators, that should be true, and it is. So next we're going to do print. Write a print statement using the OR operator that will evaluate to true. E equals F, or E greater than F. And they don't both have to be true, and they're not, because this it's an OR statement. Okay. And then we need to do a print statement using the not operator. I want to see which one it's looking for that. So there are multiple ways to answer some of these, because not would typically be a not equal to. But you can do something like this. Print E not 12. It's not going to work it that way. So we're going to do it E not equal to F. And that should work.
How come we didn't use if statements?
Because this is just supposed to be doing the operators. This is not, it's just logical operators. It's not an if, we're just printing the results. Because it doesn't say to do a if statement, it just says to combine relational comparisons using the logical operators. And so it's like we did earlier on the page where we're evaluating to see if something's true or not. Okay.
The second one,
Mm-hmm.
I put, I had D equals E
Are you doing
True.
equals equals?
Yes, and it resolved for true, so I didn't have.
So
that
you did-
Comparison.
So you did, for the second one, you did D equals equals F?
Equals E or F, and I didn't have a comparison operator before the F.
They're both, yeah, those are both valid ways because this is then comparing it to this one or to this one. So there are two correct, there are sometimes more than one right answer. So you found another right answer that's totally fine.
Sure, yeah, okay.
No, for that one I did the if else, so we can just shorthand it.
You can just shorthand it, but it's fun. I read these, so as long as you're properly using and or not, you're fine. There is more than one right answer. I'm giving you a right answer, not the right answer. You are programming a baby doll. If the baby doll is tired, it will close its eyes. If it is hungry, it will cry. Write code to print eyes open or eyes closed, depending on the tired value. Then print crying or quiet, depending on the hungry variable. So what it's looking for here, if, and this is Boolean, so I can just do if tired, which is going to evaluate to if tired equals true. So if tired, print eyes closed. Else, print eyes open. And then the next thing we're going to check is if hungry, and again, that's evaluating the same as if hungry equals true. This is a simplified version of it that the Python editor prefers. It's going to be print crying, else print quiet. And that should be that for this lesson. And we'll test it. And on here, it did ignore those things, so you're welcome to do that on those. Some of those formatting errors are really goofy. So I got my green check mark, and when I go through it and test it, eyes closed and quiet. Okay, I'm going to stop recording.